Very rewarding to see people coming together, to see one of our colleagues talk about their research here at Alliance Manchester Business School. So today we are joined by Antony Potter, who's a Professor of Operations and Supply Chain Management. As part of our original thinking series, we hear from new and recently promoted professors in Alliance Manchester Business School who are delivering their inaugural lectures. It is really lovely to see colleagues and also to see new faces come here to support Antony, and also especially to be inviting his family here to be with us this afternoon. And we are also especially pleased to be enjoying and welcoming a very substantial online audience from across the globe who will very much be part of the event today. And I gather we've got people from Japan and we've got people from Brazil, and it's really wonderful to have such a global audience here. So Antony's research focuses on operations and supply chain management, including cutting-edge innovative ideas and projects in this field. Today we're going to be hearing more specifically about how car manufacturers collaborate with their suppliers in order to co-develop and innovate more sustainable fuel cell technologies. I think we can all appreciate that as society and industries alike take further steps towards more environmentally friendly practices, areas of research like Antony's will play an increasingly vital role in helping us understand what's happening, the sort of major social changes, economic changes that are happening in our everyday lives, being able to explain them, and of course also translate our understanding and our explanation of these major changes into policy recommendations and practical recommendations as well. So Antony's work on this topic has been published in numerous leading international journals, and he has also won a number of highly acclaimed awards. Now, I am going to be slightly biased and reference two very important awards, which are those that we have given him within the school, in that he was runner-up for the 2019 Teacher of the Year Award. And it is very nice to take this opportunity as one of the two awards that I'm going to mention, that Antony is also a fantastic teacher and is an incredible teacher in terms of how he shares his knowledge with all levels of our students within the business school and across the university. So wonderful that he also was being recognised for that award, and in 2022 was Researcher of the Year Award, so here in Alliance Manchester Business School. Now there's going to be plenty of time, as always, towards the end of today's session for your questions. So again, those of you who are in the room, please raise your hands in the traditional way. And for those of you online, please type them into the chat function at the bottom of your screen as we go through the event, and one of our colleagues will look to read those out. And we try to go backwards and forwards between the online and the face-to-face questions. So the discussion and questions today will be facilitated by our colleague Zhao Huawei. Sorry, I'm going to have to struggle over this, Zhao, but I'm going to start again. Zhao Huawei Kwasi Frotonet, who is a Professor of Operations Management and a colleague of Antony's in the Division of Management Sciences and Management here in AMBS. So I'm sure that you're really pleased to get started, so please let me hand over to a very nice turn of phrase, which is Professor Antony Potter. So thank you, Antony.
Right. Welcome, everybody, and thank you very much, Fiona, for that really nice introduction. It's good to see family and friends here in the room. Thank you very much for coming along. And also thank you to the students and also managers and professionals online who've joined us today. I'm going to give you an important presentation today, really about the future of the automotive industry and about how automakers have been collaborating with their suppliers and customers for a number of years now to develop eco-innovations in electric, hybrid, and hydrogen fuel cell vehicles. So if you watch the news, you would have seen recently there's a lot of challenges, a lot of change going on in the automotive industry. We've got new powertrain technologies emerging. We've also got the government's net zero targets, new rules on ESG, we've got supply chain disruptions, we've got COVID-19 pandemic, the phase out of internal combustion engines, and as you probably would have seen on the news last night, significant concerns about price inflation. Okay, inflation running at a very high rate at the moment. There's issues around vehicle affordability, particularly surrounding the problem of the supply chain disruptions, which can push up the value of the components that go into the vehicles that we use. Yesterday, I was also reading that on the news last night, the UK is introducing a new energy security bill as well, that does have some profound implications for the energy supply system in the UK and also for the automotive industry. So there's lots of change going on inside the automotive sector. One of the key areas where we're going to be talking about today is around this top one, new powertrain technologies and how they were developed. Now, my background, my research area, my teaching is primarily in supply chain management and operations. And you probably would have seen on the news during the COVID-19 pandemic, we've had a lot of problems here, with disruptions. And everybody speaks to me and says, Antony, you're in supply chain management. What's going on? How can we fix these problems? And for the supply chain profession, it's kind of, a lot of this news is very negative, okay? So I'm going to tell you a positive story today about how automakers collaborate with their suppliers and develop the very latest innovations that we'll be using in the next 10 to 20 years in terms of these eco-innovations for different fuel cell and electric vehicle technology. Okay. Before we go on though, I want to outline a couple of quick pointers here. We'll be talking a lot about different types of powertrain system. Okay, so we've got electric motors here, batteries, power control units. Okay, now these flow through into kind of 3 or 4 main types of new technology, which we'll be talking about. We've got fuel cell electric vehicles, which take a fuel cell stack, which is from the electric motor, and hydrogen fuel cell from a high pressure hydrogen tank to drive the engine. We've then got the battery electric vehicle there, plug-in hybrid electric vehicle that merges a traditional battery electric motor with also a combustion engine, and you've also got the hybrid engine vehicle there as well. We'll be talking about these throughout today's session, okay? The structure of today's talk is going to talk primarily about those 3 main innovations, and we're then going to talk about this new one, hydrogen combustion engine vehicles. They've only recently been developed. We'll talk about some of the implications that could potentially have for the automotive sector. We're then going to look at Toyota, and we're going to pay a close attention to Toyota as a case study throughout today's presentation. In particular, Toyota has a very high rate of patenting in the automotive industry and a very high rate of citations, and has played a key role with its suppliers in developing many of the core technologies that go into these different powertrain platforms. We're then going to talk about my contribution to the literature, which is looking at how Toyota and its suppliers formed these innovations together in terms of buyer-supplier collaborations, supplier-supplier innovations, different innovation triads to basically create the core technologies that then go into form the different powertrain systems. We'll then conclude with some managerial implications and conclusions as well. So, when we talk about the different powertrain systems, think of an electric vehicle like this. So it could be, say, a Tesla, or it could be another automaker's electric powertrain system. You've basically got a very large battery, power control unit, an electric motor there. Okay. You then have the plug-in hybrid system, which basically means you have the battery, power control unit, the motor, a fuel tank as well, and the engine and the generator. That means that you can normally function the vehicle so that it can run on gasoline, and it can also run on the battery as well. It also has ability to self-charge as it drives around too. And we then have the fuel cell system there at the bottom as well. So those are the kind of 3 main approaches that many argue are the kind of core basis of the automotive industry. So what does that then mean, okay, for the next 5, 10, 15, and 20 years going ahead? So if you look at this graph, you can see the travel distance along the x-axis here and the vehicle size along the y-axis. And you can see how those 3 different powertrain systems form different parts of that graph. So the battery electric vehicles down here, which we're all kind of used to, their travel distance is kind of small to moderate, okay? And they tend to be much smaller vehicles, get a better mileage from them. You've then got the hybrid and the plug-in hybrid ones here, where if you're traveling a kind of intermediate distance, the vehicles get larger. And you've then got fuel cell over here on the right. Larger travel distances, traditionally associated, they're hoping for things like trucks, but also the Toyota Mirai, which is a hydrogen fuel cell vehicle launched in 2015. Okay, and so that's where some people argue the automotive industry is kind of moving towards. Others argue it's going to be mainly around battery electric powertrain transmission, or as the batteries become more effective, they'll start to move out into this area as well. Okay, so that's really these three main different technologies and how they relate to distance and vehicle size. So we'll look now at Toyota and see some of the innovations that they've been developing, because there's also on that graph the issue of personal mobility. If you go around Manchester here, it's a very dynamic city. You see a lot of people on electric bikes, electric scooters. Okay, went back probably about 6-7 years ago, that wasn't the case. Okay, they've also developed at Toyota different types of technology platforms, including the Toyota e-Pallet, which is like a, best way to describe it, it's like a large vehicle that you can basically go inside. It's an autonomous vehicle and it will then move around the city a bit like a large taxi. And the idea here with its level 4 automation is that during the day, passengers will join onto the actual e-Pallet system. They'll move you around the city like a taxi or almost like a tram. And then in the afternoon or evening, they can then switch over to be home delivery vehicles as well. And so they piloted this and they used it at the Tokyo Olympics. Okay, so that's one of the technologies they're doing for personal mobility. The battery electric vehicles, though, Toyota has been launching as of this year a much greater range of their vehicles, particularly the new BZ EV vehicle range. They have experimented and used electric vehicles before. The EV technology department was originally founded in 1992. They had the RAV4 EV as well, but from around 2010, they haven't had as many electric vehicles come onto the market. There's some of the reasons for that we've discussed later on, whereas other automakers have stepped in much more heavily into that area. Another area where they've been investing quite heavily is in solid-state battery technology. Okay, so they announced, I think it was this year, this is a video that you can watch online of the solid-state battery vehicle moving. So solid-state batteries are much faster charging time, and it's hoped that they will be a big step in improvements in battery technology. No automaker has yet actually put a solid-state battery into a vehicle and get it to work on a kind of normal kind of basis. So they've got a starter production date of 2024, which will be a major breakthrough in the automotive industry. Interestingly, they're looking to put solid-state battery technology into the hybrid engine, not the electric vehicle engine. Some of the reasoning for that is the technology is still quite new. So you want to practice it in a hybrid setting where you know the technology well before you introduce it into a pure electric system. They're also well known for the hybrid vehicle, to be shown here. And the hybrid vehicle engine, it's a really big breakthrough. It was launched in the late 1990s on the 4th generation of Toyota Prius. And it integrates into the Toyota new vehicle architecture as well, which means that they can move different powertrain systems inside the same underlying vehicle architecture that they have. The next one, which was launched in 2015, and this was a really big breakthrough, was the hydrogen fuel cell electric vehicle. Now, this is a really path-breaking piece of engineering. It's launched in 2015. What it basically means is the vehicle uses hydrogen from a hydrogen fueling station to run, and it produces no CO2 emissions at all. Okay? So the way it works is it takes airflow through the front of the grille, which is here. That then gets supplied into something called the hydrogen fuel cell stack. Hydrogen is also stored in a compressed hydrogen fuel cell tank as well. It reacts with the oxygen inside of the fuel cell stack to generate electricity and to drive the electric motor, with the only byproduct being water. Okay, so this was a really path-breaking innovation. To actually mass produce a fuel cell vehicle that runs on hydrogen was seen as a big step in the automotive industry. Of course, the downside of hydrogen fuel cells is you have to create the hydrogen in the first place. Okay. So while there's a lot of interest in electric vehicles, hydrogen is kind of not taken up as much due to the fact that it's difficult to build out the infrastructure for the hydrogen supply. Okay, but the good news is that we have the technology now. Okay, if you went back to 2012 or 2011, some of these systems didn't even exist except on the drawing board or in a laboratory. Okay, so what happens next? So 2015, hydrogen fuel cell vehicles launched. Okay, a lot of governments around the world then decide we want to try and ban the internal combustion engine or phase out its usage over the next 5 or 10, 15 years. Okay, a lot of governments have signed up to that. Okay, Toyota then also launched another radical innovation, which was the combustion engine that drives on pure hydrogen. Okay, so in this setting, you're using a traditional combustion engine. Okay, you're taking compressed hydrogen from the storage tank here and injecting it into the engine. It's driving the engine itself, produces no CO2 emissions. Okay, another incredible breakthrough. It took them a long time to do this. It's based upon a 1.6 litre GRS Yaris engine, like the Yaris you might see driving around here. They basically took that, they used the compressed hydrogen inside to then get it to drive. Now, it does emit a small amount of CO2 emission because when the piston comes down, it will burn some of the fuel, some of the oil inside of the tank here, a very small amount. And there is obviously the problem that it can produce some nitrogen dioxide as well. But the good news is that they're making progress, okay? And then they're moving things in the right direction. And they're collaborating with one of their suppliers, Yamaha Motors, to continue to invest in this technology in the future. Another important organization, which some of you may have heard of, is a company called JCB. They make diggers, okay? You might see them on construction sites around Manchester because there's lots of construction going on in the city centre. So you have a very big yellow JCB digger. One of the things you'll notice about this engine, though, is this is a petrol-driven engine, okay? JCBs run on diesel engines, okay? And JCB was also quite worried about some of the legislation and regulations that have been changing, and they were looking for ways to push the technology further, just like Toyota was. And so what they developed was a hydrogen-powered JCB vehicle, okay? And they did that in 2021 and 2022, okay? What that basically means is you're taking a diesel engine, and similarly to this, you're injecting hydrogen into it, and you're using that hydrogen to run the vehicle. The reason JCB did this is because, remember, most JCB equipment is used on construction sites, or they're used outside in agriculture in the countryside, where there's no electricity supply. So you can't plug in an electric JCB. And what they did in their test run is they actually built electric JCBs, and they could get them to work for about 5 hours, and then you then need to have a recharge, okay, for a very long period of time. And that caused them a lot of problems because the companies that use those JCBs need to use them from 8 o'clock all the way through into the late evening if they're doing a big construction project. And so they can't stop the JCB just to do a charge on an electric vehicle. They also invented and developed hydrogen fuel cell JCB, okay? When they experimented using electrical powertrain systems here with the JCB vehicle, one of the problems they found was weight. You take a 20-ton JCB, you then add on a 10-ton battery onto it, makes it a 30-ton vehicle, okay? You think, well, that's okay, it's not too bad, 20 tons to 30 tons. The problem then becomes is you then add on the weight of all the components that have to be redesigned and changed and made heavier to take the additional weight of the battery. It becomes a 35-ton vehicle, okay? And so there's lots of difficult decisions that policymakers and managers are having to make in this area. One of the things they also found is that they also have electric JCB diggers here for the small ones. So if you're doing a house improvement or a renovation to your house, it'll probably be a very small electric digger here, but they can't last very long and they don't necessarily work as effectively for the larger vehicles. So what this is showing us is that over the past 10 years, and incredibly more recently, there's been a lot of change. If you went back to 2010, some of these technologies didn't exist. Hydrogen fuel cell vehicle, hydrogen combustion engines were just ideas on drawing boards that they're experimenting with, but hadn't really taken off. We also had the emergence of new entrants like Tesla, who have really transformed the automotive industry, particularly in battery electric technology. Okay? So there's lots of change that's been happening. And so I was looking at this after doing a really great project with Ben Lawson at the university, who's at the University of Cambridge now. And we've been looking at how you integrate suppliers into new product development processes and how you solve some of these really ambiguous problems that occur during the innovation process. And that was really interesting because we got some really good insights by doing surveys with firms in the UK, doing case studies. But one of the downsides of that approach was we're getting very focused on particular projects and also kind of general picture of lots of different innovation projects occurring in the UK. But we weren't really capturing how the supply network as a whole creates innovations. And so that's what I decided to look at next, was looking at how one automaker and its supply chain develop technologies. Now, at the time when I started this project, I didn't know that Toyota was developing the hydrogen fuel cell vehicle and later doing investments in hydrogen combustion technology and also doing solid-state battery development. I was quite fortunate in the sense that I could see in the patents and some of the scientific papers they were publishing that they were moving in that direction. So I decided to study how their supply network developed some of those core technologies with them. Okay? And the reason I chose Toyota is another reason. This is a number of patents along the x-axis here, a number of citations by automakers. This is data just published in the Journal of Clean and Production from 1970 to 2016. So you can look here, Toyota's way out here, okay? High volume of patent high volume of patents, very high volume of citations, and that's for electric vehicles, okay? There's Ford, okay, Mitsubishi, there's Renault, Honda. There's different, you see Toyota coming up more than once here because there's different divisions within Toyota you have to account for. And you then look at the patent citation data of EV battery technology, again, 1970 to 2016. The yellow dots here are all Japanese firms, okay? So very high density of citations of patents between automakers and their suppliers inside of Japan, okay? This is the one for the States out there as well, okay? So we know that there's a high degree of innovation occurring across their whole supply network and a high degree of citation of their patents as well. Now, I also teach course units on operations management and lean production, and we focus a lot on the supply chain management practices that they use at Toyota and other lean companies as well. These are a list of the main supply chain practices that we know play an important role in improving organizational performance and also in fostering innovation, okay? So it's things like having an operations management consulting division, an internal group within Toyota that's tasked with developing their suppliers in things like the lean production system. We know that they transfer employees from Toyota to their suppliers, often in some cases for free, for extended periods of time to work on technology together. They have voluntary learning teams where they have problems inside of the supply chain they want to try and solve. They have a supplier association of their core 219 suppliers that over the past 40, 50 years they've been working with to improve their operations. So we know that some of these practices can have a real world effect. We haven't really been able to see the kind of the wood through the trees. We've been focusing a lot on particular projects, particular relationships. We haven't really been able to see how the whole network actually facilitates this process. And I was quite lucky in that Mark Lines, which is a online, it's a company that provides market information about the automotive sector, publishes data on all the supplier and customer linkages inside the Toyota supply network, but also for other networks, Honda, Mitsubishi, Tesla, GM, Ford, BMW, everybody. And so you can actually use this data to produce these lovely maps. This is actually from Keto, who was a researcher at the time at the University of Oxford, and she was the first academic to actually map the whole of the Toyota supply network. Okay, and this contains thousands of connections, hundreds of firms, okay? And you can then break out this network and look at individual kind of clusters around clean technology product or the fuel cell system or the just simple things like the vehicle lamp, all those integrate chemicals and different compounds that are used inside the plastic or inside the filament for that. You can actually break it down into different details. You can also produce networks, diagrams like this, looking at how different firms in the supply chain are actually owned and have cross ownership relationships with the automaker, but also with each other. So you might be Denso, which is a big supplier in Japan, but you may also have shareholdings in other suppliers inside of Japan as well. It also, to a certain degree, means you can then start to look deeper inside the supply network. So if you're an automaker here, then you might be buying an engine component here, then look at the company that makes the metal, the company that forges that metal, the castings, and the supplier further down. Actually map the supply chain. I've done things like that. I've actually physically walked down supply chains. I was doing my PhD in the University of Sheffield, and you'd actually have to go through and map the supply chain. Yeah, it's a fascinating thing to do. It takes an awful lot of time. But the good news now is the secondary data is available for us to start to do that. And that wasn't available about 10, 15 years ago. It's a quite new access we have to this type of technology and data sets. There's also other data sets we can use, like S&P Capital IQ, the Bloomberg system, that can provide us with a fine-grained level of detail too. So my research really kind of comes in to start to look at more of a network view of the innovation process inside the supply chain. It's important to highlight what your original idea was, okay? This is something I actually drew out on one of my lecture slides back in about 2012, okay? And I thought, right, I'm gonna look at the third generation Toyota Prius, okay? I'm just gonna think, right, let's just think conceptually, how did they develop the electric motor, the engine, and the hybrid battery? The important thing to highlight here is most of the patents are registered by Toyota, and they're only for Toyota yet. And you see the patent, you see the researcher's name, and then say Toyota Motor Corporation, or another word for Toyota. But when you start to look into it in more detail, you see the sprinkling of other patents inside of the patent database that relate to these suppliers down here. So it could be that Toyota's co-patenting with a company that makes part of the engine. It could also be that they're co-patenting with a company that makes a rare earth metal here as well. But it could also be that two of those suppliers are actually co-patenting together. In some situations, you have these strange triads emerge, which is when you have Toyota and two suppliers that all co-patent an innovation together, okay? You have other ones where the suppliers are connecting horizontally across the supply network. And I was going through these patent records, I was amazed at the amount of innovation and the way they were innovating, because that wasn't taking place in other supply networks, okay? And so I kind of separated this out into buyer firm innovations, which is between Toyota and one supplier, one of its suppliers, supplier-supplier innovations between two suppliers here, these triads, which are called supplier innovation triads, which occur between Toyota, two suppliers together, and then these clusters. You then sometimes get clustering of about 4 or 5 companies, all trying to innovate in one technology and one patent. So what that basically means is you have a patent that's registered with Toyota and 4 or 5 other suppliers and organizations, including universities, research institutes as well. And the final thing I realized when looking at these patents is a lot of them are related to Toyota's R&D laboratory too. So I looked at some of the information there. So that's really how, it's kind of a bit strange, our teaching, because I was working with the students at the time, trying to figure this out, like how come they're innovating in these really unusual ways that we don't know about in the journals, we don't know about in the textbooks. And I put it on one of my lecture slides, and I ran the idea with my students, I speak to some people in industry, it's like, yeah, it kind of makes sense. But again, we had these kind of little examples of it, but we didn't really have a full picture of why they were doing it. So what I decided to do, I decided to go through and map the Toyota supply network. And it takes a long time to do that, okay? Multiple years, okay? It's a long, hard process. Very few people have actually mapped a whole supply network. You would have probably seen about some of the supply chain disruptions that have occurred. You're probably thinking, well, how come people don't know who their supplier is or who their second or third or fourth tier supplier is? And the answer is many people don't spend the time to actually do that activity. Very labor intensive. It's very, very difficult to actually do it. So we mapped the supply network of the 219 firms inside Toyota's suppliers, the supply association, the supply network. And we then looked at their suppliers through this network as well. And what I decided to try and do is try and answer some important questions. First of all, let's take a step back and think, why is the automaker co-patenting with a supplier. Okay, so that's just when the automaker and a supplier are both registered as co-patent inventors on the network, okay, sorry, on the patent record. And that would include things like the battery pack, it includes things like the negative electrode discharge device, braking systems, fuel pressure control systems, software as well as hardware they were patented, okay? And what we decided to do is I developed this conceptual model where we looked at the relatedness between the automaker and the supplier. So relatedness is a metric that's used, published by Bryson Winter in Management Sciences. Nefke has also worked on this in Strategic Management Journal as well, where you basically take the SIC industry code of supplier, which is operating in an industry that's aligned to or close to the automotive sector. So here we're dealing with suppliers that are not necessarily in the automotive industry, they're kind of closely connected to it. Things like battery suppliers, things like companies that make parts of the chemicals that go into fuel cell vehicles, those sorts of things. And so we looked at those in particular, and what we found was the firms that were more related to the automotive industry, as you would expect, tended to co-patent together, okay, with the automaker. But it then became very interesting because we then started to look at the technological strength of the automaker and the supplier in different fields. And so what we did is we looked through the patents and we looked through the data from the databases we had, and it showed us which particular supplier was making particular components for Toyota. And we then used the patents database to identify whether particular suppliers have lots of patents in a particular area that they're making for Toyota, but also does Toyota itself also have patents in that area? To give an example, take a braking system. Okay, we'd search through the patents and record how many patents does Toyota have in braking systems? How many patents does the supplier have in braking systems? And what you find using moderation analysis is that when Toyota has a high degree of previous patents in braking systems, they don't tend to co-patent with the supplier. It's kind of what you'd expect because you've got the knowledge in-house. Why would I bother co-patenting with the supplier? On the other hand, if the supplier is an expert in braking systems, has got lots of technology and patents in that area, then Toyota will tend to want to patent with them, okay? So in other words, to put it more bluntly, if I've got a background in an area, lots of engineers who specialize in it, then I don't need to worry too much about co-patenting with suppliers. If I don't have a background in the area, then I'm going to patent with them a lot, which kind of makes a lot of intuitive sense. The next thing we were looking at was then the moderators for technological dynamism. What this basically means is that if the industry, we calculate how many patents have basically been published in, say, braking technology over the past 4 years. And in areas where there's a high degree of innovation, technological change, then they basically involve their suppliers in a different manner. In this situation, what happens is if there's a high degree of innovation in the industry, lots of dynamism, then they won't tend to co-patent, okay, because the technology is still developing and moving forward. They tend to co-patent when the technology is more mature, okay? And that makes a lot of sense from kind of like a safety and a quality control point of view. So that explains why automakers or a particular automaker co-patents with one supplier, okay? But it doesn't give us the full picture about what's going on. Remember, inside the supply network, you also have suppliers co-patenting with each other. And so we mapped out the supply network in a similar manner here to Peto's diagram. And you can then see these little clusters of firms that emerge for particular technologies, okay? And what we then started to do when we mapped it was to figure out why particular firms are co-patenting with other suppliers together. And this will include things like fuel injection nozzles, hydrogen fuel cell technologies, electric power conversion systems. What we found is the more linkages the firm had within the supply network, the higher degree of co-patenting with other suppliers. However, if they have lots of linkages to customers, so you might take a firm that's got lots of links to other customers inside the network, that doesn't always result in a positive relationship, okay? Now, the network and academic theory literature would suggest that the structure of the supply network plays an important role in determining who they patent with, okay? Particular measures like betweenness centrality, which measures whether the firm is a broker or a key player according to the number of connections in the network. We find out that that's not actually important for supplier-supplier innovations. We also find out, interestingly, that the closer the firm is, according to its closeness centrality, its kind of freedom within the network, often towards the center of the network, you tend to find less supplier-supplier innovations occurring. Most of the supplier innovations are happening at the periphery. Okay? Same thing with small world clusters. You tend to find that these supplier-supplier innovations are bridging clusters within the network. Okay? They're not necessarily occurring that frequently within these small world clusters, but they're acting as bridges between different small worlds in the network. You also find a much higher degree of supplier-supplier innovation within Japan. The more manufacturing plants the firm has in Japan, much higher density of supplier-supplier innovation. So the final couple of things I want to talk about is about these other forms of network structure that get less attention in the academic literature. Professor Tom Choi from Arizona State University was one of the first people to highlight the importance of what we call supplier triads. Supplier triads are a collection of 3 organizations that collaborate together. They can occur in many settings. So, for example, here at Manchester, we had linkages with Toronto University and also with Melbourne as well. That acts like a triad. Yeah, we share knowledge, those sorts of things. That can also occur within supply networks. And this is a paper by Aurora and Brinda, published in 2021. That's all the supplier triads inside the Toyota supply network. There's hundreds of them. Okay? And what we find is that, strangely enough, there's a high degree of patenting between the automaker and 2 suppliers on one patent. And you don't find that in many other automaker supply networks. Okay? One of these very unique features, which is a high degree of supplier-supplier innovation and a high degree of supplier triadic innovation, is what we didn't expect to see. And that's in things like battery management systems, electrical connectors, which kind of makes sense because you have to get a battery maker involved in the innovation, as well as the software firm, as well as the company developing the electrical connectors as well. They all need to be together in the same innovation. Now here, for a triadic relationship, it's a lot more complex. And as a result of that, the automaker has to have good leadership relationships. So we then took data on the automaker and the supplier's board of directors. We found that those boards and senior leadership teams that have lots of ties and connections with other firms in the supply network were much more likely to result in these supplier triadic relationships. Okay, and so that's where, for example, you might be on a top management team or a board of directors, and you also have an advisory role on another organization in the supplier, inside the supply network. But we found as well that if they had lots of linkages to external firms outside the network, it basically stopped these relationships from being as strong. Okay, whereas alliance partner diversity, lots of alliance partners you might have, was found to be beneficial. Final things just to kind of touch upon now. My next research is looking more at the kind of clustering effect, which is when you've got multiple suppliers co-patenting with Toyota. So you've got suppliers in the supplier association, as well as universities, research institutes, and you've got more of an ecosystem of lots of firms collaborating together, often in things like mobility services that are being given and used there as well, where there's a greater role of universities playing a role in that part of the network. The final thing to mention is about the role of innovation inside the R&D lab. This is an important thing to highlight. In the UK, we tended to have had a lot of investment into universities, which is a good thing for R&D. But in the private sector, there's been more of a downward slope, particularly in America, in terms of private sector R&D labs, okay, big industrial labs that we used to have 20, 30 years ago. And what we found looking at Toyota's central R&D lab is that it has a lot of good connections with the suppliers, but also they look at core technology in terms of powertrain, battery fuel cell systems, but they also deal with the social sciences, much more increasingly recently in terms of data analytics, social systems, and lots of other technology and how consumers are going to be using Toyota's technology in the future. And so looking at these sorts of relationships, we then looked in particular at the knowledge that's spilled over in patent citations between Toyota Central Labs and the automaker suppliers, particularly with something called concurrent sourcing, which is when you have when the automaker makes a component but also buys the component from another supplier, single sourcing relationships, long-term, and also the centrality of the firm inside the network and its relationships were all found to increase patent citations, okay? Particularly if the supplier had a star scientist or a research center, it also played a role. The final couple of things to mention is looking at, how do we measure all of this? Okay, so we look at patent data, we look at supply network data, we look at data on buyer-supplier relationships. You think about it as layers in a cake. Okay, you've got innovation at the top in terms of patent data, you've got citations above it, you've then got a layer of management relationships between boards of directors, another layer of relationships in terms of strategic alliances, and you've then got the supply network underneath. And we then use statistical and econometric techniques to basically show that these relationships exist, and we test them. This is quite important for the more junior staff who are here, the new lecturers and senior lecturers. It's important to make sure that we learn some of these techniques. They're the ones that are used to add a higher degree of validity and robustness to our data. It's things like endogeneity analysis, looking at past data, current data, and the future. Can you predict which firms are going to innovate in the supply network based upon your analysis? That's what one of the reviewers asked me to do from a top FT50 journal. They said, great study looking at the past 4 years, fantastic results. I want you to predict for the next 3 years what's going to happen to those innovations. I was kind of, oh my God, it's a really complex thing to do. So I went away, back through the patent databases, downloaded the data, stuck it into the model, and it worked. So the structure of the supply network can actually predict, to a certain extent, it's not the perfect model, but it will predict which firms are going to innovate inside the network in the future. Okay, and that's quite a big step from an econometric point of view. We also test our relationships, not just looking at patent data, but also looking at scientific research data as well in terms of those variables. And we also replicate some of the data using different automakers as well. Okay, so the final couple of things in terms of managerial implications. The importance of investing in an R&D research laboratory is very important. And a lot of firms sometimes tend to want to not do that because of higher costs. Look at things like lean production, lean NPD activities to improve the innovation process. And from the supply chain point of view, it's important to map the supply network, okay? Not just for finding disruptions and bottlenecks, which we've all been focusing on, but for mapping innovations and where technology is moving in the future. Then build good leadership relationships with those suppliers that are developing that technology. Use lots of supplier relationships to embed that as well. And think about developing some of these more complex co-patenting relationships in the network. The final thing to highlight here is this, which is where my research is going to focus a bit more in the future. Looking at the total production system and how it improves productivity and lowers the costs of the vehicles and technology. Because that really is the stumbling block now, okay? We know how to develop the technology, okay? And a lot of new technology platforms have been developed and they will be developed in the future. We've got to find a way to make it more affordable that we consume, for us to consume, given that the inflation rate is where it is at the moment, okay? So a quick, short summary. There's lots of new powertrain technology evolution in the automotive industry. It hasn't stopped, it's continuing to evolve. There are different ways to innovate with your suppliers that weren't normally fostered in previous decades of the automotive industry. So it's not just about the new technologies we all tend to focus on, they're actually innovating in a brand new way as well. Okay, and that's something that doesn't tend to get picked up in the literature. Of course, there are some limitations for this single study with one supply network and looking at patent data primarily, which does have some significant limitations. In terms of future research, I'm continuing looking at innovation. Look at more how other automakers' networks operate and how the networks change over time. But increasingly, I'm going to focus a lot more on productivity in the automotive industry and how we can tackle some of the productivity puzzles that we have in the UK as well. Okay, I think I'm just about on time. So I hope you guys found that useful, and I'm happy to take any questions with Professor Zhao.
Antony, for the very interesting presentation, which sure you enjoyed it as much as I did. So here comes the part where we organize the question and answers. So anyone, I'll start with the audience here present. Anyone has any question? Please raise your hand. Conway, please.
Thank you. That's a really interesting lecture. I think I can see from your last slide you acknowledge some of the limitations, and I was thinking something similar is the network analysis you have done is a single supply network, and then you only focus on one. It's a very kind of car maker centric network.
Yes.
So in that sense, that relates to my question about because Toyota basically is a big company with it's very powerful. And some of the hypotheses that you proposed, I just wonder whether that could be applied to other automakers. Because in your hypothesis, you have mentioned that the moderating role of some of the network position of the supplier. So I wonder if you take a full network analysis, that means that supplier also have its own network with other automakers and their network and so on. So all of this, I just wonder whether that kind of a hypothesis, or maybe you need to consider even more moderators in that sense. So that's probably something will be even more interesting for future research. So speaking of that, I just wonder how much you are really taking into account the potential explanation of power relationship, basically.
Yeah, it's a good question. So we do have a paper I wrote with Stephanie Graham at Queen's University where we compare the data sets between Toyota, Honda, Nissan, Mitsubishi within Japan. And it's interesting how with the suppliers for electric and hybrid engines, there is quite a high degree of consistency. When you look at suppliers for fuel cell, it's very different. I think what's happening there is Toyota has internalized a lot of the fuel cell technology development in its own R&D center, its own R&D labs, whereas other companies have basically relied upon suppliers to do that. So you have a very different situation inside of the supply net which it operates. When we ran the models with other automakers, we primarily looked at Japan. The reason for that was when you look at a lot of the battery electric vehicle supply base, a lot of the innovations are often connected to Japan for that. We're looking at other automakers. It's one of the great things about being at Manchester University. We have lots of MSc students come, and they're very good. And I sometimes speak to my students and have a dissertation. I basically say, okay, so I have this model about how I think it works in Toyota in Japan. Let's just do a summer project for your dissertation. How does it apply at, say, for example, Tesla? So we've mapped Tesla's supply network and then reran the models. Okay. Now for that one, we've ran models for the firm level innovation, how much innovation the firm has, not supplier, but just firm. And what we found, we're looking at Tesla's supply network, it's very different. You tend to find there that the more centrally you are positioned in the network, much higher degree of innovations, but particularly you've got direct connections to Panasonic, which is what you'd expect because all the battery technology does come.
I just wonder whether that relates to potential moderator, is how the technology actually is essential to the core competence.
Yes.
Which probably, I'm not seeing that you identify a lot of moderators, but probably relations to your core competence might be another moderator, whether you want to co-patent or not. Because to some extent, we need to consider the motives. Right? Why they co-patent? It's not just for common good. Sometimes it's for protection for other reasons. So I guess those kind of issues we also need to consider. Yeah.
So that's a good question because what I did in the analysis is I'm running a model with all the suppliers in the Toyota Supplier Association. But what you can then do is you can do something called split sample analysis. You can take out the firms that are not developing powertrain system technology in electric, hybrid, and fuel cell vehicles. And when you run that, the results are much stronger. So that was one of the great things of the paper is that in the FT50 paper, Journal of Operations Management, we rerun the models with only including powertrain system technology. And all the results are much higher, which is exactly what you'd expect. So in other words, these innovations are not entirely, but they have a higher degree of intensity amongst firms who are developing electric, hybrid, and the fuel cell system. So in other words, there's still patents in the network that are developing improvements in, say, wiper blade technology, or it could be in the glass that's used inside of the vehicle screen. But that's not part of the powertrain system, if that makes any sense. So the intensity is mainly in that battery area for the future. No, it's something I'm definitely testing in my future papers. It's a good question. Yes, good luck.
Okay, I'm not familiar with the automotive manufacturing, but in the aerospace manufacturing, you have the concept of risk-sharing partners. Does it exist in the automotive to some extent?
It's a good question. I mean, to an extent, it probably does. I think the interesting thing with aerospace, so I've done some work a long time ago with Bombardier in Northern Ireland, and they would think with suppliers when they developed the new plastic composite fuselage for their aircraft. And some of those sorts of relationships are very common in aerospace, but I'm not so sure how common they would be in the automotive industry. I think if you're dealing with very complex projects for battery systems, for the design of the chemical compounds that go into the battery, you're going to have those sorts of relationships. But for the supply relationships where it's a small R&D project and they pack together, you're probably less likely to have that.
So the financial project of a new car is entirely responsibility, the financial side is entirely taken by the OEM.
In general, yes.
In general, yes.
Yeah.
So I was just thinking, if you did have risk-sharing partners, maybe there will be some interesting kind of influences on the innovations and on patenting.
Yeah, the only exception which I think you could make to that is a company like Denso. So Denso makes a lot of the core technology for many different automakers. It's a bit like Magna in Europe. They would have the ability to make a lot of this technology, and they may themselves have those sorts of relationships with second-tier suppliers. So,
Okay, so maybe it's on the second tier, on the level of tier 1, tier 2.
That's right.
Okay, thank you.
It's good.
I think I'm not playing favorites here, but I think Marie has a question in the back.
I was intrigued by what you said, Antony, about that it took you years to map that supply chain.
Yes.
Toyota. So I have two related questions on that. The first is, are you chasing a moving target here in the sense of how stable are these supply chains? So by the time you've, I mean, I don't want to depress you, but by the time it could be changed already. So how stable is that? And
Yes.
the second question is, in terms of lessons to be learned in terms of supply chain transparency for other firms. I mean, this is kind of it shows how difficult it is to actually map a supply chain. So did you learn any lessons from that could be useful for companies who want to map their own supply chain, or maybe researchers who want to map supply chain, things to do, things not to do?
So the good news is with the Mark Lines database, Bloomberg, S&P Capital IQ, there's some other archival research to be published as well that you can use. You can download the data relatively easily.
Okay.
But going back through the data, all those lines of relationship, that's the part that takes the long time when you then construct your database to then using the software, the statistical analysis. It's that part. If you can download the data fairly rapidly, but you then got to go through it line by line and check every single one, and then make sure it's the correct component, correct supplier, those sorts of relationships. You can then use network software like Delphi or Usenet and other programs to build the supply network diagram that I'm showing you on there. That's the part that takes the longest. It's we were chatting about this previously. It's the data cleaning and the data wrangling that's the hard part, and it does take months and months to do it. In terms of transparency, though, it's something I think that, if I'm honest, in the supply chain literature, we've paid less attention to. We've primarily focused on buyer-supplier or firm-level analysis. We haven't really looked at supply networks. Most of the papers on supply networks have come out since about 2011 because we didn't have the databases. We now have the databases, and it's thanks particularly to Alliance Manchester Business School that we have these data sets here, because most other firms don't have access to that at all. We do get, in the private sector, supplier approval lists, other forms of tracking that you can use, but that's often, it's hard to then replicate in other supply networks and firms. So you can use the data to go through it, but the problem is just going through line by line doing it. And it's thousands and thousands of observations. Okay. So my poor family had to put up with doing it. But yeah, it's worth it in the end. When you see the results, it really is genuinely very impressive. It's good.
I think Fiona wants to.
Yeah, if I may. So three things, if I may. I purchased an electric bike.
Okay.
Started that journey and just thinking, does all this sort of work go on to obviously other products? And I suspect the answer is yes, because of course, I spent a lot of time looking at or feeling the weight of the frame and the weight of the battery and all those sorts of things, and realizing all the innovations that are going on there. So maybe that's just an observation. A couple of other things is, have you talked to Toyota about your work in terms of, have you been telling them things about things they didn't know themselves? Because there's this outside looking in and getting this incredible view of what they're doing, and talking to them and sharing that information and their reaction to it and what they know and didn't know. And then thirdly, I was interested in where you were put in the spot in terms of journal, in terms of predicting the future, which is quite tough territory, isn't it? And I don't know, how did you manage that? Was Toyota part of that prediction? And how easy it is to kind of predict something that's happening now and think that it is going to translate into another sector and all those sorts of things.
Yeah, so to take your first question on how does it relate to other electric vehicles and devices, there's quite a lot of overlap in there. I'd say that the technology overlaps is definitely the case, but where I see some differences is in how some supply networks seem to have quite an insular focus to innovation process. The firms and suppliers innovate by themselves, potentially one other or maybe another firm, but not form triadic relationships or the complex 4 or 5 partners on one project. I think that's probably something that's a bit more unique to Toyota just because of its size. You can actually do that sort of thing. In terms of links to the company, I've had a few. Not necessarily to discuss my research, I think it's been on more other things. I've mainly had more contact with other researchers who do work on Toyota within the academic literature and within the kind of automotive industry space. So, for example, Miriam Wilhelm is, I think she's actually joining us today. She's an important professor at Groningen University, does research on the supply network, and she's done studies with Toyota as well before in the past. I've had some connections with some of the other parts of my future research projects I want to do, but I haven't really shared too much of the data yet because it's only just been published in the past couple of years, so it's probably early days yet.
And then just in terms of
the prediction. Yes, the prediction was an interesting one. That was from I don't want to mention the journal editor or the journal name. They basically said, great model, fantastic. Really interested in it. The review process has been 2.5 to 3 years. So they basically said, this is a long review process. We'd like you to rerun the model to really explore reverse causality. So what you could make an argument is that firms that are more innovative and have lots of time, so they might reposition themselves in the network to be closer to other people that are innovating. And they basically said, we also want to see whether your model works, but trying to predict the number of patents and where they're going to innovate in the 3 years since the study was formed. They basically said, go back and into the patent database and re-record for the 3 years from 2015 to 2018, the future patents that have occurred since the data set. And I spent about 5 or 6 months doing that, stuck it into the model, and it worked. And I was absolutely amazed that, in other words, the structure is actually helping to not predict, it can explain the past, but it can also start to show some of the relationships that emerge in the future as well. But I think one thing that there's a limit to that, which is that that's also subject to a lot of caveats in terms of which variables you put in the model. It's a standard assumption test. But also the technology is changing so quickly that it may not apply to some of these newer technologies. So the hydrogen combustion engine, it may not necessarily apply to that. That's something that's very unique, that's only came out last year. So that may not necessarily be captured in those data sets.
Do we have time for other questions?
Yeah, a couple, yeah.
Thank you, Prof. For that, I think I got many things new. And you mentioned the relationship and networking in your lecture. It sounds like a close relationship-based supply chain. And when it comes to the partnership and close relationship, several words across my mind, like commitment, transparency, trust, collaboration, etc., etc. And I definitely believe those things could be beneficial for innovation. On the other hand, are there any potential risks for the knowledge sharing, information sharing? optimism, and practically, what recommendations we can provide with those companies to manage those risks?
Yes, it's a good question. So there is research that's been done, particularly in the survey data in the UK, which has shown the importance of buyer-supplier relationships, of trust, long-term commitments. Paul Cousins is quite a big person in that area. That has shown it often acts, sometimes, not always, as a moderator. So the stronger the relationship, the more better the knowledge sharing will kind of flow through. In terms of opportunism, that can happen. There's no doubt about it. But there's also, actually, like to build on your comment, just thinking about it, there's also a third thing you've got to worry about, and that's the lock-in effect. So if you're in a technology that's moving very quickly, you might be locked into the wrong technology. And you could make an argument that, particularly with Toyota, they kind of missed the boat a little bit with the growth of electric vehicles. They could make the vehicles, but they chose not to really prioritize that area and focus more on hydrogen and hybrid technology. I think personally for me, some of that lock-in effect was due to the unique circumstances in Japan. When they had the earthquake there, you had a situation of the electricity supply wasn't that reliable afterwards, and there may be some concerns about that. It wasn't just Toyota, it was other Japanese automakers invested heavily in hydrogen for that. So you do have to be careful about the network structure, because it can lock you into the wrong technology platform, and your supplier or customer could act in an opportunistic manner for that. One of the ways you could look at that is to look at litigation. So the extent to which each of these suppliers is suing each other in court over a breach of contract, which is something that we're looking to do in the future. Not at Toyota's network, in other networks, looking more at kind of the S&P 500 level.
Okay, and one more question. Do you think we should keep the core technology privacy for the companies confidential, maybe? I mean, when we do the knowledge sharing, we identify the strategic supplier to share our core knowledge and keep the core knowledge, confidential.
Yes.
In this case.
Yeah, so that is a big problem, which is the downside of patent data, which has been well known. It does cover around 90% of the R&D activity, according to World Patent Office. If it is really core technology, you may not want to put it in a patent, because there's a risk that other people could use the patent as a way to reverse engineer your product or to claim that they invented it. That can happen. So some companies don't patent because of that. But the risk of that, though, is that another company could launch that innovation, and because you've decided not to do it, you can't then claim that's my innovation. So not all inventions are covered by patents.
So for the co-patents, so it sounds like, when the supplier has the advanced technologies, we do the co-R&D, or we have the co-patents, but from the side of Toyota, they have the advanced technology, they maybe keep the core technology confidential. So actually, I think it's the advantage of the advanced knowledge or technology of our suppliers. Is it?
Yeah, so that's in terms of the power dynamics between the buyer and the supplier. So when one has a lot of technological advantage in one area, they may act in a different way compared to when a supplier has a lot of advantage in one area. And that's what that first paper really kind of picks up on.
Okay. Thank you.
I think if we have time, we have one question.
Very quickly. First, thank you for a really good presentation, and I think I have to pick your brains on how to try to look at the suppliers. So I miss your explanations out too. I was thinking, on point of talking actually to your understanding, I was curious about how they organize the R&D labs and also their approach to patenting, as we know in the automotive industry. I mean, the patents might be limited in some instances.
Yeah, one of the interesting things about the labs is they have a very good, they have their own journal which they publish. And in that journal, they publish all their scientific papers which they're working on. And it's fascinating when you read it, because you can actually read the scientific journal paper and then see some of the patenting that's done and then actually connect the two. So it's actually a fascinating thing that they do. And the unique thing about them is that they also have lots of core engineers in science and technology. But they also have what you might call like a humanities department as well, social sciences, looking at how society is changing, how people adopt different technologies. But I think for them, that's just as important as the development of the actual innovations, because we as consumers, we've got to buy that technology.
There's a strategy dimension that really interesting. I remember in my teaching this paper, it's research policy for IBM on how to use networks over time. They wanted to change the strategy completely, and they use strategic alliances to move. It was very simple compared to obviously. But I think having 4 years doing a similar exercise over periods like that, this is how to do the team strategy. It's really use different use of the supply networks. Really idea.
Yeah, it'd be good to see how the kind of patenting and the scientific innovations change over time. It's all recorded in the data sets.
Good. Are we done? Oh my goodness, I'm going to have to stop people here.
Can I just add that?
Please do.
That the questions that you posted online that we cannot answer, Antony might want to.
Yeah, sure.
I can have a go at those.
Yeah, I'll go at those.
After the lecture, of course.
Yeah.
Yeah. No, we certainly do use the opportunity to write blogs, answer the questions, and so on. But we'll certainly use the opportunity for the wider online audience. So, can I just say a big thank you to Antony, as of course an electric bike purchaser recently. It was just really interesting to hear. And just really fascinated by a company and all the investment it's doing and the R&D, because you hear so much about how that's not happening in lots of places, of course. So really just fascinating to hear all of that. And I'm sure there are lots of other questions. Thank you to Jal for facilitating the discussion. For you all here in terms of some of the questions and the discussion we've had, and also thank you to, as I said earlier, the very substantial online audience from around the globe. And we will take the opportunity to pull in your questions and write that up. And sometimes we'll do an extra video session or something like that with you, Antony. So we try and make lots of opportunities to follow on from this. So really interesting lecture, and thank you very much for that. We, as usual, have a series of events, and our next one is going to be hosted by Sheena Johnson, who's going to be looking at research with impact, focusing on health and well-being, an ageing workforce and COVID-19. So that is going to be next week. So do please join us for that. And can we all take this opportunity of thanking Antony for his wonderful work. And before we clap, to say that please join us all in the front as well. Those of us face-to-face, I'm sorry the online audience can't join us for a drink, but join us for a drink in the void to celebrate his promotion to being a professor as well. Thank you very much.